It's hard to perform automated testing of an LLM. We can no longer assert that expected is equal true, since an acceptable response takes so many different forms. LLM judges have emerged as a solution to this problem, but theory tells us that LLM judges agree with human judges to the tune of approximately 85%. But would this also apply to your particular domain and its use cases? And what if an LLM judge could be more than just a test oracle? What if it could be used to improve a product rather than to just test it? Welcome back to Beyond Quality podcast. I'm Maria, quality engineering lead at Regent.
I'm Vitaly, I'm a developer advocate and now a researcher at Case.
I'm Anupam. I'm head of AI testing at Test Solutions.
Beyond Quality is an open source community for deeper inquiry. You can find us at beyondquality.org. Well, this episode is centered around Anupam's inquiry about LLM judges here on Beyond Quality platform. And I'm wondering, Anupam, could you please walk us through it? And it's really interesting to know what got you asking this question in the first place, and what was the moment you realized that you need a better way to judge LLM output.
Yeah, I think it started last year. There's one of these days I decided to open ChatGPT, and instead of using it like a user, I decided to test it. And that's when I noticed that testing this thing is going to be different because thus far we've relied on consistency and we have relied on consistency to validate or even verify if an application is working properly using automated tests. But here we have an application that is stochastic or probabilistic by design. And therefore, testing it is not going to be easy based on consistency. And that's where, as you said, we can no longer rely on static assertions. So once you present a particular question or a query to an LLM, it can give you, if you present the same query several times, it can give you answers of different forms. All of these answers might be valid. So we need to validate the essence of the answer, what the answer means, rather than the form, right? And this is what led me to LLM judges, because I think there are several machine learning techniques that were used for assessing these stochastic outputs. But I feel like, with time, LLM judges are becoming the standard way on the standard method that is used for how to tackle this problem. Let me quickly explain what an LLM judge is. So once we have, and I mean, like, let's say you have an LLM as an application that you want to test, or at least a component of that application has an LLM to it, and or any generative component. It need not be language. Once you have this output, you can then prompt another LLM to act as the judge. So this LLM is exclusively prompted to scrutinize the output based on certain rubrics to produce an answer as to whether this output is acceptable or not based on certain standards. And you can do this out of the box, or in that you take an LLM and you just say, you just take two LLMs and you just say, LLM one is producing the answer, the other one is evaluating it, and then you're looking at whether those answers are acceptable or not. Or you can align it with human judges. But I think I'm jumping ahead now. So in a nutshell, LLM as a judge is to use another LLM to validate the output of the first one.
I would quickly jump in here because when you presented this inquiry, it I had recollections of, I recalled previous attempts in our industry to assess in some way systems of higher complexity. For instance, chaos testing emerged simply because we accepted the fact that we cannot even possibly combine results of testing of each individual system, which is within our huge system, to see how reliable the whole system is and how it behaves if one of the component breaks. And I would say that we kind of, our industry, even before LLMs, kind of drifted towards understanding that with just deterministic testing, where you give input and expect exact output, we cannot reason about the reliability or how good the answer of the whole system is, how good the behavior of the whole system is. And so inevitably, when LLMs emerged, they brought even more stochasticity, and that we had to invent some new ways to assess it.
Actually, Vitaly, you're touching upon a very interesting point. I think how we be doing automated testing, which is a snapshot of how a system works at a certain time, and whether that's green or red, is actually already kind of broken. It's actually kind of an approximation. And in many situations, as you mentioned, even that is not sufficient. We knew this already, but this truth wasn't uncomfortable enough, and we could brush it under the carpet with LLMs and these non-deterministic systems. This truth just becomes too uncomfortable for us to ignore anymore. And now we need to finally actually go ahead and tackle this. Because I think stochastic variability exists in any system that has a certain level of complexity.
Well, backups. I mean, we did backups ages ago, right? I mean, hardware should be reliable, should be, but well,
Right.
we plan for actions when it's not.
And more pragmatically, we just added retries to our automated tests, and once at least one of them was green, we were like, okay, yeah, this is good enough for us.
So true. Yes, so there are two hypotheses sitting behind this inquiry, and I want to take them one at a time because I think each one is approaching the problem from slightly different angles. And the first hypothesis is that an LLM judge can be calibrated by one or more or a group of domain experts before it's actually useful. Anupam, why does that calibration step matters so much?
Right. So let's take LLM judges without calibration out of the box. I mean, LLMs these days are working well enough to answer a broad range of generic questions pretty well, and they are only getting better. I mean, I think they are even getting better to certain extents in several domains as to how they answer questions that you would that are expected. And this is mainly a function of the kind of training data. So they are really good at answering questions that are available in the open internet. They the companies that are building these have focused a lot on the software development domain, so now they are really good at answering software based questions, and slowly they are branching out to other domains based on where they find the most business values. And this varies from LLM to LLM. So each provider, like for example OpenAI, will have a better sense of domain A vis-a-vis Anthropic will have a better sense of domain B. The reason I'm speaking about this is mainly to talk about how if you use an LLM judge out of the box and if you build a prototype, you're likely to get really good responses off the box. And this is what we have seen even in academic research, where for a generic list of questions, there is what you stated as being 85% theoretical agreement. This study goes back to either end of 2023 or beginning of 2024, and it was performed with GPT model 4.1 by a group of researchers from UC Berkeley. I mean, mainly UC Berkeley. There are a couple other universities involved. And what they found was that an agreement rate on across 8 subjects between LLMs and LLMs, or LLMs and human judges, were, the agreement rate between human judges and LLMs themselves were about 85%, and human to human agreement in a lot of these subjective questions was also around 80%. So that shows that the threshold of human to human agreement has been crossed in this case by the LLM out of the box. Nevertheless, I say that through practical experience, and this is something that demos really well, but in practical experience, I've also had many people speaking about how they've used LLM judges in production and not seen it to work to this tune of, the promised value of 85% sadly doesn't arrive. And this is mainly because once you get into production use, you get into several nuances and you get into several data points that are needed to be assessed that a generically trained LLM has no access to. For example, if you're looking at the airline domain, there are several rules that are interpreted by experts, domain experts, based on their past experience, which are not necessarily provided in user manual. And therefore, like, let me give you a sort of nuance here as an example, right? Like, if you many flights have rules for how you take animals aboard, but there might be a nuanced distinction if that animal is a pet or an animal is a service animal. So the same, in this case, both of them could be dogs, but they might be treated differently based on whether they are a service animal or a pet, right? And an LLM is not likely to have the training data to make that nuance that ascribes to the particular airlines, how the particular airline wants it to be interpreted. And because LLMs are great at filling in the blanks, they are likely to come up with a policy on the spot, which can actually land your company in trouble. So, I mean, long story short, there is lots of gap filling that LLMs do, and they can do it in a manner that can land your company in court if you use an LLM out of the box. So this is why we need calibration of LLMs.
I would also add here that LLMs generalize. When we speak about mathematical problems, they are already generalized, right? So two scientists reasoning about one mathematical problem, their reasoning will be similar. Well, their ways of approaching the problem might be different, but LLMs can perform well there. But as you've said just now, two different airlines will have absolutely sometimes different policies. Take Ryanair or any other low coaster and compare it to Etihad business flight, right? The rules will be very different. So unless we have a reliable way to add context, knowing that the LLM will use that context, 100% sure, then we cannot rely on an LLM to be specific to our context. And that is why we need some form of slapping the LLM, like making sure that it will reply in a certain way.
That's really interesting. Yes, and the second hypothesis is the bigger claim, I think, and it's that a calibrated LLM judge isn't just a way to catch the defects or the variations, right? Instead, it can become an instrument for the ongoing improvement and maybe improvement of the whole AI system or your product as a whole. And it seems like a move from just using LLM judges as test oracle or testing machine testing frameworks to using them as process improvement mechanisms. How do you see this playing out in real life, in practice?
Right. I mean, I think it helps to draw a distinction between verification and validation, which is a classic in the field of testing. So verification is ascertaining whether a system meets a certain spec, whereas validation is to ensure that the system is satisfying a user need effectively. Any specification is a proxy for whether something satisfies a user need, and therefore it's an approximation, right? So verification is more approximate than validation, and validation typically has only been performed by humans, whereas verification were done by automated testing, done by automated testing. Now, the difference between an automated test and a human being is judgment, because an automated test is great at following rules, but I think how I define judgment here is how you interpret the spirit of the law rather than the letter. The letter of the law is the specification. The spirit of the law goes beyond what is specified in the letter, and therefore humans are able to perform validation. And now, when we are looking at LLM judges, we are also relying precisely on their ability to make judgment calls here, because they have to go above and beyond the exact specifications. In many cases, they have to go above and beyond the exact form of the answer and look at the spirit of the answer and extrapolating from there. So if we can abstract some judgment and save it as a good enough proxy at an LLM judge, might we be able to extend this judge from verification to validation? Now, that's the that's the center of this hypothesis. But the second hypothesis, in my opinion, depends a lot on the first one, and it's already hard to get the first one right. So therefore, the second hypothesis is a bit of a long shot. As you said, it's more exciting, but it's more of a long shot because it makes several assumptions as to these LLM judges being fit for validation rather than verification. Because I think there are many stages when it comes to leaping from verification to validation. And before, I mean, when you're talking about, I mean, like, let's look at those stages. The first one is, does my product meet spec? And the second product is, is my product good enough to use? And the third level is my product improving? So each of those leaps requires a quantum of judgment that is greater than what was there before. And this is the hypothesis that I propose that I'm less certain about.
I would reframe this as, when we had automated tests, or TDD, we were trying to capture the intent for the module, or intent for a piece of a system, for a function. We're trying to see whether this intent is actually there, where, if it's satisfied, if this little part of the system satisfies what we wanted it to do. So we were trying to do some automatic assertion of this particular module. But the higher you go, like from unit to component to system to end flow tests, the harder it is to write them, the more fragile they become. Mm-hmm. But the more valuable they become, I would argue. Because in my opinion, maybe I'm controversial here, but I don't care about the code at all. I think the code is a liability unless it gives us expected behavior of the system. And this expected behavior is very important. What you've said, Anupam, is very important. We need to satisfy clients. We need to make their lives better. It is such a vague thing to make clients' lives better. But it is exactly why clients bring us money and their loyalty. So in my ideal world, we would have a way to quickly and regularly check if what we are building makes clients' lives happier. In our industry, we have so many things for that. NPS metrics, CSAT metrics, coverage. We think that coverage matters. We have come up with so many things that we think compound into this one proxy of, are we making clients' lives happier? And in my opinion, what we had before with automated tests and TDDs is very far from really capturing if we are making clients' lives happier. And your whole inquiry motivates me to think about this particular thing. How can we define a proxy of a client, if I may say so? How we define a proxy of the behaviors that clients like? For instance, with a chatbot, it's pretty simple. It sounds pretty simple. We define what we look what clients want from the chatbot, and we define a certain number of ground truths and how the LLMs have to respond to those to the answers based on those ground truths. That is possible with calibrated judges. Already possible. We can do that. Now, for me, the most curious thing is beyond that. Can we grab experts' knowledge and turn it into calibrated judges, meta judges, whatever you call it? Can we use LLMs to be checking and verifying and assessing what we're building more often than I, as a human, can possibly do? I can't do exploratory testing 24 hours a day. And even if I could, I would only capture one part of the system because I need to redo it all the time. That's the beauty of the LLM here. We can seriously exploit. We can run 50 LLMs if needed for 50 different proxies and see if each run matches our calibration. That's the avenue I'm really curious about.
No, you bring up an interesting point that takes us back to hypothesis one, right? Like, which is um, that, I mean, first of all, in fact, this is even beyond the hypothesis. This is like any benefit that you get with the automated testing as such. Um, if we've looked at LLMs and we've spoken about how the evaluation of LLMs has to involve judgment, and what a lot of teams do is they use humans in this to provide this layer of judgment, and this works. But this is simply hopeless at scale, because you have two different requirements. One is that you need this validation on the part of human experts. On the other hand, you also want to iterate on your product as fast as possible, and with every iteration it's simply not feasible to get the human to perform a thorough test as to whether everything is working. And that's why a lot of teams, what they end up doing, and this is really dangerous, is they end up doing a vibe test. They end up changing something in the system, checking 5 questions. If those 5 questions work well, they push to production, and then it fails spectacularly elsewhere in very unexpected ways. So this is actually the fundamental problem that an LLM judge already solves. And with calibration, it is going to be solving this in a more precise manner. Without calibration, it could be including noise into the system, lots of noise into the system, and even a measure of bias. Because if you are training on data that is available in the internet, there can be biases that creep in just due to due to how the machine learning process involves correlation, which which can easily spill into causation, and drawing causal outcomes, which ultimately results in bias. So, I mean, to your point, I think being able to build AI applications at scale is going to require that you master a technique like LLM judges.
I would also add here, just quickly, that very important aspect we've touched briefly is that, as with end-to-end tests or any other automated test suite, it became stale within just 1 month if it wasn't maintained. With calibration for the LLM judges, maintenance is even of a higher importance. You fairly said that LLMs bring bias. New models emerge. We usually just install them. We'll change the key, right, to the new model, and we rely on the producers of those LLMs to have less bias, which might not be true. Who knows? So, in my opinion, the faster we go, the more we will have to invest into maintaining the calibration suite of some sort. But it is just one effort. So we maintain the calibration, and then it's automatically revalidating everything all the time. This is the beauty of it.
Yes, that's really interesting. I think our listeners would like to hear some hands-on advice, and I suggest that we get really concrete here. Let's say I'm a test specialist and I want to calibrate my LLM judge properly. Where do I start?
No, I mean, I think what you can do is, let's take a concrete example and actually work with this example. Let's say we are working with an airline, and we are looking at customer support for this airline. So the domain expert in these cases would be experts who have been doing customer support for a long time when it comes to answering customer queries and so on. So you take one of these domain experts who have seen thousands of customer queries, and you get them to talk about what kind of queries come most frequently, what kind of queries are most tricky to resolve, which are the ones where they had to escalate to a manager or discuss among themselves to be able to resolve. And you write these queries down to form something called a ground truth list or a golden data set. Now, what this golden data set has to give you is some sort of a basis, right? Like, this is, it's broad enough to cover several, the diversity of questions, the tricky questions that you are likely to encounter when it comes to customer support. And at the same time, it's deep enough that these questions are non-trivial and they require like more involvement from an expert. perspective. So once you have this set, then you can give these questions to your LLM chatbot, anything that is meant to serve as a proxy for these experts who are working, and then see the kind of answers that it gives, and then have the same experts validate whether that answer is acceptable or not. And through this process, the degree to which the answers are acceptable is the degree to which that system has a higher degree of fidelity. That is, it is a valid proxy for the customer support representatives. Now, if you take this one step further, you give the let's say you design a validation exercise for you design a validation exercise for a list of ground truths, and you determine, let's say we take 50 ground truths, and the experts determine that for 45 ground truths the answer is acceptable, and for 5 ground truths the answer is not acceptable. You give the same ground truth responses to an LLM judge and see if the judge also has a 45 to 5 split, and whether those 45 are the same 45 that the experts also pointed out as being acceptable, right? Like, so you're looking at the alignment rate between an expert, a domain expert, and an LLM judge. A couple of tips on how you design these ground truth questions. The temptation often is to use metrics that go in a particular scale. How acceptable is this answer from 1 to 5? I would actually propose that people go for yes or no validations, because that gives you a clearer basis. A domain from a domain expert perspective, an answer is either acceptable or not, because otherwise you would end up with numbers like 4 and 5, and you enter debates as to what is the difference between a 4 and 5. These are not standard. That's one tip that I have. Another tip is whenever you're looking at evaluating any particular response, provide clear evaluation criteria to the LLM judge. Now, these evaluation criteria could be at a meta level that they have to observe for all questions, and they could all, that this could pertain to something like tone of voice, or like the brand voice that a particular company has to use. But it could also be specific to any ground truth question. So for any particular question, let's say it is about baggage allowance on business class, so then there will be clear criteria on, hey, this is our baggage allowance policy, so this is criteria 1, criteria 2, and criteria 3, and those have to be checked when that particular answer is being evaluated. So, that is in a nutshell. In fact, I would say that I would encourage listeners. What I'm trying to describe here is actually far better demonstrated than explained over voice. And there are demonstrations of this. And I can link to a couple of talks that I've given where I actually demo this out. So I would encourage you to check those things out. And I hopefully what you see there will be much clearer than what I'm explaining here.
Cool. Vitaly, you have a lot of hands-on.
I actually listened to Anupam's talk. I had a pleasure. And we will also publish the repository for this talk, because the repository, in my opinion, as a developer with some experience, is self-explanatory, even if you don't watch Anupam. But it's just a pleasure to watch Anupam, so do.
Yes, sure. Vitaly, you also have a lot of hands-on experience with evals. Do you have anything to add in this section? What are your best hands-on advice to someone who wants to start with evals?
I would even step back and say that, as it should be done in all quality assurance and testing, when we're building something, I believe we should start with thinking why we're building it, how we can assess whether we built it the right way and whether we built the right thing. Because that's the same thing we did with TDD. That's the whole premise of the TDD, that we define the executable specification, whatever you call it, executable verification of what we want to build, and then we build it. In my opinion, this mindset shift, that you first define what you want, and it doesn't take a 1 year planning, it's just a matter of one module or one subsystem. Only then you build it. Because when you first think how you're going to be validating it, you build it in a very different way. What I am doing now is I have a few personal assistant kind of agents, which are just Claude, living in separate repositories, doing separate types of work, like say conference planning, etc. And I'm building now evals for these agents so that I know that it won't hurt the budget file if I change my LLM from Opus 4.8 to Fable 5. So I want some confidence in the changes I make. My experience is that when you think about what you want to build and how it needs to behave, evals come quite naturally in a few steps. First, you get an understanding whether your system, your agent, your LLM-enabled system is stable, that it actually returns you what you want and behaves in a way you want. And only then you build assessment and judgment using calibrated evals of what it is giving to you. Like first is a smoke test, kind of it replies all the time with something meaningful. Second is the judgment part. And the judgment part is the most interesting one. That's why I recommend watching Anupam's talk, because he very neatly explained the difference between the judgment and validation there. I don't advise any tips and tricks. I would suggest that people clone the repo from Anupam and play with it, but then think how an LLM-enabled app could help them in their work, unless they already have some LLM-enabled app, and think how it would be possible for them to verify, validate, and assess and judge how this LLM-enabled app works. Because we all making fun of McDonald's and other companies who have chatbots where users ask them for Python code and chatbots reply. We all make fun about security issues introduced by chatbots. But are we that different if we do not know how to actually make sure with some good probability that our agent, our chatbot will not be behaving like that? I am not that confident yet. I need to work more on calibration.
And Vitaly, one more thing that I was reminded of when it comes to your analogy with TDD, which is actually a powerful analogy, is once you adopt TDD, you realize that the code of your, the way you've built a solution also needs to change. So TDD is not just a basis of, just not just writing a test, but it actually changes the way you even develop. And to go one step further, in some cases, it can even change the way you build your application. Because when you test your application first, you realize that, the application isn't actually satisfying in the way it is specified, isn't actually either recognizing certain cases that will arise or satisfying certain customer needs. Now, the same principle applies for LLM Judge calibration, because during the process of calibration, you don't just test, or you don't just calibrate an LLM. Firstly, you are looking at what criteria you're using to verify your system. So you're bridging that gap between verification and validation. You're making sure that your specifications are closer to what users need because you're doing this iteratively. I mean, whenever I'm looking at LLM Judge calibration, I go ahead and actually also change the criteria that I've defined. I also go and tweak the ground truth questions that I have defined to make them a little more tricky in a lot of cases. And in several cases, I'm also changing the data that is used for producing the answers themselves. So it's an iterative process of improving several parts of the system simultaneously by just virtue of doing this disciplined and structured exercise.
I would also add that you're very right that thinking about testability, what it was called before testability, now it's going to be availability, whatever the new world will be, changes the way how you design the applications. For instance, there are so many people now speaking about semi-autonomous agents which do multi-step flows, like grab information from one place, convert it using some logics into something different, put it into another place, then do something else. And First question I ask, how do you even test this? If it's just one agent doing the whole flow, how is it even possible for a human to test it, let alone a calibrated judge? So if we think about the testability as a good constraint, then we will design these multiple flows in separate steps, each one calibratable and calibrated with a judge. And then we can see, okay, this step started to misbehave. Or for this step, we can change the model to a much cheaper one. Or for this step, we need a more expensive model. And this step might be even become deterministic with a Python script or whatever. So thinking about the modularity and the testability, in my opinion, has direct economic outcomes, because now cost of change gets slower. When you have just one flow, you cannot test it. You cannot verify if your change destroyed everything or just a part or improved something. Well, it's just bad for everyone.
Yes, basically what you're saying is that calibration isn't a one-time event. And at some point, the judge needs to be recalibrated because the product is changing, the models are changing. And I'm wondering what actually triggers that need for change or for recalibration.
No, I'd actually pass on this question to Vitaly, because I found his answer to my inquiry on this topic to be really insightful.
Thank you. I would say that calibration, maintenance of calibration, speed of maintenance, or the amount of effort we put into that process depends truly on how fast we want to change our system, on how quickly we want our system to be adopted to the new changes from the outer world and from us as well. Because if our system changes once a year and everything is fixed, maybe we can just calibrate like once a year, twice a year, that's it. Just do some maintenance. But if our system adapts to the changes from the outer world, we inevitably have to invest a lot into the calibration, because calibration drifts really quickly. I would even say faster than the suite of end-to-end tests. Say we're developing a normal application and we have an end-to-end test suite. We would always change the tests when we add new functionality or change functionality. That's like a requirement. We know we must do it. For an LLM-enabled app, in calibration, we capture even more abstract stuff. And that is why it is much more important to review it all the time. But again, it doesn't add waste, in my opinion, simply because we do it once in one place. Calibration set is just one set for a system. So we have an expert, as Anupam suggested, for an airplane company, a customer support expert. That expert should be the knowledge owner for this calibration set, in my opinion. Because they would know, sitting on the phone, they would know what issues come. They would know what new regulations emerge. They would know what new rules the airplane company introduced recently. So they would be the source. Agent cannot go and ask the directors of the company, are there any rules? So it has to be the human who does it.
Right. And I mean, as for the calibration triggers themselves, Maryia, thanks to Vitaly's response, there are broadly three factors that we've identified. The first one is coverage, in terms of if we have new features and new functionality, naturally, the calibration exercise needs to be performed again. The second thing is what we call freshness, which is like, say you were the set of features you're testing is the same, but the basis on which you're testing them is different. For example, you're using a higher model LLM. You're changing something fundamental about the system. So then your calibration becomes stale, and therefore freshness is another trigger. The third one is fidelity, and this pertains to the degree to which your LLM judge can reasonably be a proxy for a human being. And there are several cases where your human judgment is, unquestionable. These are cases where your customer service agents will escalate to a human being, right? And when you're looking at when you're looking at something that has changed because a regulation came up and your fidelity of your process goes down, that's another trigger for calibration.
Right. And my understanding is that you can't calibrate, or it's impossible to recalibrate everything at once and everywhere all the time. So, how do you recommend to decide where to spend the most efforts first?
I mean, I'd say firstly, you have these three triggers, and you can define some sort of metrics around how these triggers are changing, and or even if like if you're not mature enough, or if there's not enough data to define good metrics, you can do this on the basis of gut feel, but on the basis of in a structured manner by using these three triggers. Um, on the other hand, you can also look at even if you have performed a perfectly calibrated exercise and you're receiving user feedback that is completely contrary to what you would say even a domain expert has validated, that's another trigger for calibration. And this calibration would be performed by using user feedback, not just by using domain expert feedback. So you would need things like good monitoring and tracing for you to be able to capture that user behavior signal and then pass on that signal back to your calibration exercise.
I would also add basic risks can be a good framework for thinking about which part are the most important. I'm just imagining, but if we come back to the airline example, cancellation, refunds, and purchases, in my opinion, are, again, I'm not an expert, more important to keep extremely up to date than, say, traveling with bicycles or skis. I'm just imagining, but still.
No, I mean, I think the risk-based approach here just cannot be stated enough, right? Like, I mean, it cannot be emphasized enough, because this is all about risk-based testing. This is where your expertise as a human being and as a tester really comes to the fore. And this is one of the reasons why I found this exercise and this research task of digging deeper into how you test LLMs far more interesting, because I think in a lot of cases you make the judgment call as to what you are going to test deeply, because all these tests are expensive, both in terms of time as well as in terms of money. They take long to execute, they have like a high latency, and every single test involves token costs.
Yeah, right. The good old one, risk-based testing, is always good to have in mind. And okay, as we wrap up the discussion, I would like to hear your thoughts about on how much of what we just talked about, what we've just discussed, is actually very specific to LLM judges, and what could be, or is there anything that our listeners could apply more generally in testing and in their day-to-day jobs?
Well, this is actually an insight that I got by posting this inquiry and reading Vitaly and Rahul's response. What I realized is that when we look at LLM judges, I mean, I was looking at principles on how you calibrate an LLM judge, but these principles apply to how you broadly calibrate any evaluation that you perform for an AI system. Several principles can be adopted from good old testing, because I think we kept coming back to risk-based testing. We've kept coming back to several other concepts that we can borrow readily, but there are certain nuances and differences here where we lean on experience from, say, machine learning. But to your point, I think I mean, like, when you're looking at calibration for an LLM judge, you would look at, I mean, I think every automated test set needs to actually be calibrated, because we know from practice that every regression test that is automated maybe years ago or months ago becomes stale, right? I think the principle of calibration is not new. It's just like we said in the beginning of the episode, it just makes it impossible to avoid in this case, because the drift of the system is so fast.
I would agree that I would even say that nothing new emerged. I would say that, as you've said, it's impossible to ignore the drift, the risks, the reputation damage, everything which comes if we do not pay enough attention to understanding what it is we're building and how we can assess and validate and verify that we build the right thing and we built it the right way. In my opinion, there is good deal of technical knowledge that that anyone, every listener should get. Try to test your own LLM agent. Try to test a ChatGPT. Try to test anything, just to see how to get your hands dirty in actually doing the thing. Because maybe your next job, or maybe your current job, will demand from you as a tester, as a QA engineer, to start doing this. Who knows if your company employs another chatbot or does something else completely. And your knowledge here on how to run this and how to build this will be very important. And I would always encourage people to think on a higher abstraction level. Again, what we are building, why we're building it, who knows when the system needs to change, when the tests for the system need to change. How is this knowledge captured? Automated tests is one way of capturing the knowledge of how the system has to be tested. Calibration with LLM judges is another way to capture this knowledge on how the system should be tested. So first think about the principles, then dive deeper into the tech.
Great. Thank you very much for this amazing conversation, Anupam and Vitaly. And to summarize the conversation, if there is just one thing that I want listeners to leave with, it's that a judge is only as good as the calibration behind it, and that it's an ongoing process. We'll drop a link to all the research papers that we mentioned, to the Anupam's inquiry on Beyond Quality, and to the amazing talk of Anupam that won the Best Talk Award on this year's Hero Star. Congrats, Anupam. And of course, we would like to hear from you on Beyond Quality. Leave your comments on this inquiry and also on many other inquiries that we maintain on Beyond Quality. And that's it for this episode of Beyond Quality podcast. Thanks for listening, and until next time.
Yeah, just one note to add, Maryia. I mean, I think what we did differently in this episode from our previous episode is we based this episode on a discussion on the platform.
Right.
And going forward, this is the format we'll be using. So we encourage listeners to check out these discussions and participate in future discussions, or to also have a chance to appear on our podcast. Right. I mean, I think this is one shift that we made from our episodes earlier, and my gut feeling tells me that this worked very well in this episode.
Absolutely.
Yes,
Thank you so much.
Thank
it was
you
a
very
good
much.
episode.
And until next time.
Thank you. Bye.